Ladies and gentlemen, welcome to this meeting, the April 2023 meeting of the Sacramento Valley Astronomical Society. My name is Raj Dixit, president of the society. Tonight's presentation is about the Herschels, and with particular emphasis on Caroline Herschel, who was the first professional woman astronomer. So I'm going to share my screen. All right, can you guys see that?
Yes.
Okay, so this is about the Herschels, the William and Caroline Herschel, not husband and wife, brother and sister. So William Herschel, the greatest visual observer of all time, and his sister Caroline, the first professional woman astronomer in recorded history. That is Friedrich Wilhelm Herschel. He was born on November 15th, 1738, and died on August the 25th, 1822. He was born in Hanover, in what was then the Holy Roman Empire, in what we now today know as Germany. He was the fourth of 10 children born to Isaac and Anna Herschel. Only 6 of those 10 survived to adulthood. That is Caroline Lucretia Herschel, born on March 16, 1750, and passing on January 9, 1848. Also born in Hanover. Again, back then it was the Holy Roman Empire and not Germany. She was the 8th child and 4th daughter, though only she and her sister Sophia, who was 17 years older, survived to adulthood. So of the 4 girls, only 2 made it to adulthood. That's the lovely city of Hanover, in what's now Germany. And that is the only depiction of a Hanoverian Guard military band that I could find, the only decent one. Now, why are we seeing this image, you may ask? Isaac Herschel was the father of Friedrich Wilhelm and of Caroline. He was a musician, an oboist, a bandmaster in the Hanover Military Band Guard. And he saw to it that all the kids got good educations. This was helped by the fact that the public schools in that part of Germany were the best in Europe at that time. Isaac was quite interested in astronomy himself. He took Wilhelm and Caroline stargazing. He taught them about the brighter constellations. And as kids, there was a naked eye comet that was visible in the sky, and their father took them to see it. Now, sadly, at the age of 10, Caroline contracted typhus. She went blind in her left eye and stopped growing. She never grew taller than 4'3". Her mother cruelly decided that, well, because of this, Caroline's never getting married and therefore does not need any more education. She'll never be anything more than a domestic servant. Caroline wanted to become a governess to earn her independence, but her mother forbade her from learning French or from learning advanced needlepoint, which was required to become a governess in those days, and stuck her with all the household chores. She could only learn rudimentary needlepoint or dressmaking from her neighbors. Isaac and Wilhelm would secretly give Caroline lessons in the violin and other subjects while her mother was away. Wilhelm and his older brother, Jakob, eventually became oboists themselves, and they played in the Hanoverian Guard regimental band. Wilhelm could play oboe, violin, harpsichord, and organ. He composed 24 symphonies during his lifetime. He also composed several concertos and various pieces of church music. In the year 1755, the Hanoverian Guards were ordered to go to England, because at the time, the King of England, George II, was also the King of Hanover, the very close relationship between England and Germany in those days, hence the term Anglo-Saxon. When France invaded Hanover, the Guards were called back. In late 1757, when Hanover suffered a serious defeat at the Battle of Hastenbeck, Isaac sent Wilhelm and Jakob back to England because he was afraid for their safety. Although Jakob had been discharged from the army, Wilhelm was accused of desertion. Now, eventually, Wilhelm was pardoned in 1782 by King George III. Yes, my fellow Americans, that King George III of England, the one against whom we fought our Revolutionary War. The 19-year-old Wilhelm rapidly learned English and changed his name to, instead of Friedrich Wilhelm Herschel, Frederick William Herschel. And he always went by William, just as in Germany he went by Wilhelm, used his middle name. William worked as a musician in several English towns. He eventually became an organ player in a chapel in Bath, England. He became director of public concerts for that city. After Isaac died, William and his brother Alexander, who was also living and working in Bath, brought Caroline to England in 1772, even though their mother didn't want them to do that. William personally went back to Hanover to take Caroline with him. He wanted to free Caroline from the drudgery, and he wanted to teach her to be a singer and thought she would be very helpful in helping him run his household. And Caroline loved being in England. She changed the spelling of her name from Carolina, the German with a K, to just Caroline with a C. For the next 10 years, William and Caroline were busy and happy together. They were musicians. Caroline learned to play the harpsichord and became the principal female singer at performances where William would conduct religious music. He sang first soloist for Handel's Messiah in April 1778. And then she was offered an engagement at the Birmingham Music Festival. However, she refused to sing unless William was the conductor. So her career as a singer declined after that because William was spending less and less time on music and more time on astronomy. As early as the year 1773, William's interest in the stars had taken off. He acquired and studied numerous books on math and astronomy, and he rented small telescopes quite often. He was unhappy with the poor quality of these scopes, so he decided he would try to build his own. He loved looking at the moon and the planets, especially Saturn. Most telescopes of those days were refractors, but William preferred Newtonian reflectors, as he was unhappy with the lens quality of the refractors of those days, and he wanted greater aperture. It's much easier to accomplish with a mirror than a lens. That is a refractor telescope, a modern refractor telescope, much nicer than the refractors of those days. Now, a refractor works because there's a lens at the front, okay, and in this picture, the lens is 120 millimeters or 4.7 inches across. But a refractor has a lens. It gathers the light from the star or the planet or whatever you're looking at, and due to the curvature of the lens, it bends the light and focuses it to that point. And at that point, excuse me, there's an eyepiece here, which acts as a magnifying glass to magnify this image, bringing it to your eye. The eyepiece brings the image from the point of focus and magnifies it so that your eye can register it. That is how a refractor works. To refract means to bend. A lens bends light. Okay. Now, refractors in those days had a problem. You may remember this illustration from school. It's a prism raking white light into the colors of the rainbow, the spectrum of color. Now, that caused a problem in early refractors called chromatic aberration or color error. If you look at a lens, the top and bottom of a lens are basically prism-shaped. And so when they bend incoming light, the colors scatter and they can't all be brought to the same point of focus. And thus, when looking at a bright object, look at the moon. This is the moon in a cheap telescope or cheap binoculars. Notice the blue color fringe and the yellow discoloration. That is the chromatic aberration caused by poor quality lenses. And back in the late 1700s, pretty much all lenses were poor quality. So that's why William preferred the Newtonian reflector. That there is a picture of a Newtonian reflector. This is a Newtonian reflector telescope. Okay, pay attention to this telescope. Look at that beautiful machine. Don't pay attention to this dweeb. Yeah, this guy keeps coming to SVAS meetings. I don't know who he is. He looks kind of skeevy to me. I wouldn't trust him if I were you. Anyway, next, how does a Newtonian reflector work? That's a 10-inch Newtonian telescope. Back there is a mirror 10 inches across. Light from a star, planet, or galaxy enters the front tube, hits the parabolic curved mirror at the back. The curvature of the mirror bends the light to a secondary flat mirror up top, and that flat mirror bounces the image into the eyepiece. Okay. Herschel acquired tools and equipment from an optician who had just retired, and he got himself to work. He would spend 16 hours a day grinding and polishing mirrors for various size scopes. Now today, Newtonian telescope mirrors are made out of Pyrex glass with aluminum coating, 94% or higher reflectivity. Back then, they didn't have any glass that you could get that curvature with. So his mirrors are actually made out of speculum metal, a blend of copper, tin, and antimony, with only 66% reflectivity. That metal was also quite prone to tarnishing, especially in that wet English climate. So William had to make several mirrors for each telescope, and he would swap them out as needed, and with the mirrors needing to be repolished. Caroline would actually feed him while he worked, as both his hands would be busy grinding and polishing. And that's what you see on screen is the utterly real thing I've just described. Caroline feeding her brother while he's grinding a telescope mirror out of metal. Now, at first, Caroline was a little bit displeased about this astronomy stuff because William's obsession with astronomy reduced her opportunities to work in music. She wrote in her memoir that she felt like, quote, a well-trained puppy dog under his command. However, she herself rapidly became very interested in astronomy as well. She learned to polish mirrors, and so did their brother Alexander. She copied out astronomical catalogues and materials that William had borrowed so that William could have copies. She learned how to record, reduce, and organize William's observations. He began keeping a journal of his observations on March 1st, 1774. And she learned how to record his logbooks with speed, precision, and accuracy. In December of 1779, William was studying the moon through a small scope he had set up in front of his house. An eminent doctor named William Watson happened to walk by and asked to have a look. William let him look, and the next day, Dr. Watson came back, thanked William, and invited him to join the new Philosophical Society of Bath, a group almost as prestigious as the SVAS. Herschel agreed, and he became a regular contributor. He wrote dozens of papers. Through that society, he met Neville Maskelyne, the astronomer royal, who was quite impressed with the quality of William's telescopes. And in March of 1781, William and Caroline moved to a new house. That is the house they moved into, 19 New King Street in Bath, which today is no longer a residence. It is now the site of the Herschel Museum of Astronomy. That is the preserved workshop and tools of William. These are what he would use with the help of brother Alexander and sister Caroline to make telescopes in this workshop with those tools. That's a close-up of some of the tools he used to make, shape, grind, and polish the mirrors. This is a replica of a 6.2-inch f13.5 Newtonian telescope built by Herschel. This is the telescope he used to discover the planet Uranus. And he called it a 7-foot telescope. Not because the mirror was 7 feet across, because that's almost Hubble size. Hubble is it's a little under 8 feet across. But back then, when they said 7-foot telescope, it meant that the total focal length, in other words, the distance the light traveled from mirror to eyepiece, was 7 feet. Okay, that's how they discuss. That's how they describe telescopes back then. Today we would call this an 8 point. I'm sorry, we would call this a 6.2 inch telescope. Herschel's first deep space work involved double stars and multiple stars. He eventually published 3 catalogues of those stars with 848 items. His work in this area was quite important. He carefully recorded the position angles of these double stars and multiple stars, which made it possible for future astronomers to calculate the orbital periods years later. And these observations were made using this 6.2 inch reflector telescope. What you see there is a star called Beta Monocerotis. It's a beautiful triple star system that William discovered in the year 1781. This is a wintertime object in the constellation Monoceros, which is in the sky. It would be to the left of Orion. And Monoceros means unicorns, the constellation of the unicorn. And William described this as one of the most beautiful sights in the heavens. It is a lovely star with a gold main member, primary, secondary, and tertiary are both bluish. Now on March the 13th of 1781, William saw an object that appeared to be a small disk, a very small disk. He thought it was a comet, or he thought maybe this is a nearby star that can actually resolve into something other than a pinpoint. He observed it more and more, and he noticed that it was moving. And he realized this is not a star, this is a planet beyond the orbit of Saturn. Being a good Englishman, he named it Georgium Sidus, or the Star of King George, after his monarch, King George III. In France, which was not on good terms with England at the time, they did not want to call it that, but the astronomers did want to honor the discoverer. So, according to the French Academy of Sciences, they named it Planet Herschel. In the year 1782, German astronomer Johann Elert Bode proposed the name Uranus, because just as Saturn was the father of Jupiter, the new planet should be named Uranus, who was the father of Saturn in the old myths. And that became the official name in the year 1850. That there is an image taken by the Hubble Space Telescope of the planet Uranus. As a result of this discovery, William was elected to membership in the Royal Society of England. He was introduced to King George III and the royal family. William's friend, Dr. Watson, petitioned the king to grant William a pension sufficient to allow him to quit music and become an astronomer full-time. That petition was granted, with William becoming King's Astronomer to George III, which is different than Astronomer Royal, who was in charge in those days of the Royal Observatory at Greenwich. William and Caroline left Bath and moved to Datchet, which is near Windsor Castle, in the summer of 1782. William's pension was actually less than what he was making as a musician, but with King George's encouragement, William opened up his own business of making high-quality telescopes and selling them to observatories and universities and astronomers all over Europe. And through that endeavor, he made considerably more money than he ever could have made as a musician. King George himself personally bought 5 scopes, each one a reflector with an 8.8-inch mirror and a 10-foot focal length. William built about 400 scopes during his career. In the year 1783, William built his most famous and most useful telescope, the large 20-foot telescope. It's a Newtonian reflector with a primary mirror of 18.7 inches across and the focal length of 20 feet. Okay? Hence the need for scaffolding to hold it up. And to climb the 20 feet, you need the 2 stories required to get to the eyepiece, which is up here. It was completed in the autumn of 1783. It's an F12.8 design, and it became William's favorite. In 1787, he discovered 2 moons of Uranus, named Titania and Oberon, those names inspired by characters in Shakespeare's Midsummer Night's Dream. He discovered those two moons with this scope. He also discovered two more moons of Saturn, Mimas and Enceladus. Keep in mind the moon of Mimas, that moon of Saturn, it's only 250 miles across, and it's 1 billion miles away from Earth. And yet, with this telescope, as far back as 1787, he was able to see it. Just truly a remarkable accomplishment. Now, in 1782, this is our last look at the large 20-footer. But in the year 1782, William made a simple, small, low-power refractor telescope for Caroline with a very wide field of view. That way she could sweep the sky for double stars, nebulas, and comets. The next year, he made a 4.2-inch Newtonian with a 2-foot focal length, f5.7. With that scope, Caroline personally discovered 2 comets and 11 new nebulas and star clusters. This is that 4.2-inch sweeper Newtonian that William built for Caroline. This beautiful object is NGC 253, the Sculptor galaxy in the constellation Sculptor, also called, nicknamed the Silver Coin galaxy. This is 10 million light years away, and Caroline discovered this galaxy in the year 1783, the first galaxy ever to be discovered by a woman. I would point out that even from Sacramento, this object is pretty low in the sky. From England, which is further north, it barely gets above the horizon. Luckily for Caroline, there wasn't as much light pollution or air pollution back then. This lovely object, the open cluster, standing out against the rich background, but this is the open cluster. This is NGC 7789, nicknamed Caroline's Rose. It's an open cluster in Cassiopeia, which he discovered in the year 1783. This object is 7,600 light years away from Earth. An open cluster is an accumulation of young stars. This is a bunch of young stars that all form together out of the same cloud of gas and dust and are still gravitationally bound. They're younger than our sun. Our sun is about 5 to 6 billion years old. This is much younger than that. But eventually these stars will disperse and scatter and fade into the uniform starry background like you see behind it. This is comet 2P Encke. It was discovered by several astronomers. Apparently the first one to see it was French astronomer Pierre Méchain. Caroline discovered it independently. It was named after Johann Franz Encke, the German astronomer who first calculated its orbit correctly. It orbits the sun every 3.3 years, and it is the cause of the annual Taurid meteor shower. This is a really weird cartoon made after Caroline discovered that comet. Apparently, the artist was threatened by the idea of a woman astronomer. Caroline discovered a total of 8 comets, but her observing time was drastically cut because she became William's full-time assistant with the large 20-foot telescope. This is a depiction of William on top of the scaffolding and Caroline with a small writing desk beside him. Because the 20-foot telescope was so huge, the eyepiece is literally 20 feet in the air, it required 2 men just to move it. It usually took 15 minutes to aim it at any given object. If William saw a new object, he had to climb down from the scaffold, go inside, write it down in his logbook, which ruined his night vision, then go back and climb 20 feet up. So Caroline helped out by setting up a little workstation next to him, and she would take dictation as William looked through the eyepiece. William used that massive 20-foot scope on sweeps of the sky. At first, he'd point the scope at a given point and slowly move it eastward, using a constant magnification of about 157 times. With the field of view was pretty narrow, only about half the size of a full moon. Okay. So yeah, a pretty narrow, pretty tunnel vision scope. So it was difficult and laborious, and he wasn't getting good results. So he decided to change the sweep method. He would point the scope at a certain area of the sky, William would observe the universe drifting by. Eventually, the scope would be raised or lowered by 2 degrees vertically, never horizontally. William would just watch the sky naturally progress, noting down any new nebulas or clusters, and Caroline would take notes as William yelled out the observations from the eyepiece. Now, that new method yielded just astonishing results. By the end of June 1784, after 8 months of sweeping, 445 new objects had been discovered. On the epic night of April 11th, 1785, 74 new nebula were discovered. Galaxy season, most of those were galaxies. They were called nebula back then because nebula being Latin for cloud. Most celestial objects, even star clusters, especially to the crude objects of those days, looked like clouds, hence the term nebula. So William and Caroline kept incredibly busy. They would make scopes during the day, observe every clear night. In 1786, Herschel came up with a new telescope design, the Herschelian telescope, illustrated here. He modified the Newtonian design. He got rid of the secondary mirror, and he tilted the primary so that the light would come in, get bent by the curved mirror, and then go straight into the eyepiece. Remember, in the traditional Newtonian, there's a flat mirror. This mirror is not tilted. It sends the light to a flat mirror, which puts it into the eyepiece. Herschel cut out the middleman, no secondary. That does cause some distortion, but because this had a long focal ratio, that helped minimize the problem, because longer focal ratios produce sharper images. And the image was also much brighter because there's no loss in the reflection from the secondary mirror. And Caroline also invented a new way of cataloging objects. Rather than relying on old star charts, William had made some star charts. He would use them to establish where new objects were using stars as reference points. Caroline had the idea of creating a new system. She made a new catalog based on the distance between any new object and the North Star Polaris. And then every morning after the observing sessions, she would review the notes, make calculations, and write down a log of notes of all the formal observations. She called her work Minding the Heavens. Now, pleased with the Herschel's productivity, King George III approved William's request to build an even bigger telescope, a 40-foot telescope, a reflector with a 48-inch mirror and a 40-foot focal length, f10. It was not a success. The mirror weighed 2,118 pounds, and the scope was simply just too difficult to be moved or aimed, despite the crazy system they came up with of pulleys and levers. It simply wasn't, it was too unwieldy. The mirror would freeze up or frost up too quickly. It was so heavy, it would flex and bend, ruining the image. And in the damp climate, it would very easily tarnish. No new nebula or star clusters were ever discovered with this huge telescope. It was only used on occasion to make more detailed and close-up observations of previously discovered objects, and also of Saturn and Uranus. But on the bright side, it did become sort of a tourist attraction. William developed a system for cataloging nebulas and star clusters, the ones he discovered. He arranged them into 8 different classes, then numbered them chronologically by the date of discovery. More than 75% of the objects he discovered are galaxies, although no one at that time even knew what a galaxy was. Class 1 are bright nebulas. Most of them are bright galaxies, and some of them are globular clusters. This is Herschel 152, meaning Herschel catalog, class 1 object, 52nd of such objects discovered. This is the globular cluster, NGC 7006 in the constellation Delphinus. A globular cluster, unlike an open cluster, is very tightly packed together and consists of the oldest stars. Open clusters are young stars. Globular clusters are very old stars. They're packed together in a tight, dense ball. There can be 100,000 or more such stars in a globular cluster. Class 2 objects are what Herschel termed faint nebulas. Most of them are distant galaxies. This one is NGC 7814, a spiral galaxy in Pegasus, 489 million light years away. This is H2 number 240. Class 3 of his objects are very faint nebula, which are smaller and or very distant galaxies. The one here, this one, NGC 3605, is an elliptical galaxy in Leo, H3 number 27. Class 4 are planetary nebulas. This is NGC 6826, the blinking planetary nebula in the constellation Cygnus, H class 4, number 73. Now you may be wondering, what is a planetary nebula? It has nothing to do with planets. This is a dead star. This is a star more or less the size of our sun that ran out of fuel and blew off its outer layers, leaving nothing more than an expanding ring of hot gas and a white dwarf at the center. So why is it called a planetary nebula? Well, when they were first seen in the crude telescopes of those days, they didn't see this much detail. It looked to be a small disk. What else looks like a small disk in a telescope? Planets. So at first, when some of the objects like this were discovered, astronomers thought they were finding previously undiscovered planets. They soon realized, however, that they were not planets, they were nebula, because there were no visible orbits. They remained stationary in the sky. They didn't have visible motion the way the planets of our solar system do. Okay. Class 5 is very large nebulas. We saw the Sculptor galaxy, which Herschel classified as a very large nebula. And this is H5 number 24, the Needle galaxy, NGC 4565, a spiral galaxy in Cohen Berenices. Some of you may be wondering, what is all this NGC stuff you keep mentioning, Mr. Dixit? Don't worry, that's coming. It will be explained. And we wouldn't have these NGC numbers without the Herschels. I will explain how it all ties together. Class 6 of the Herschel objects are very compressed and rich clusters of stars. These are mostly rich and bright open clusters or globular clusters. We already saw Caroline's Rose. This is NGC 2506, an open cluster, again in the constellation Monoceros, H637. The seventh type of object, class 7, are pretty much compressed clusters of stars. These are moderately rich open clusters. This is NGC 457 in Cassiopeia, an open cluster that's often known as the OWL or the ET cluster. About 150 stars, and this is about 7,900 light years away. And why is it called the OWL or ET? Well, if you imagine those are eyes, and that's a torso, and these are arms, those are feet, and you use your imagination, you can see where they might get an owl or ET out of that. And the eighth class of Herschel object are coarse, scattered clusters of stars. These are large, scattered open clusters. This is NGC 7243 or H875, an open cluster in the constellation Lacerta, 2,800 light years from Earth. On May the 8th, 1788, William married a wealthy widow named Mary Pitt, née Baldwin. That, combined with his telescope sales, meant that he would never have to worry about money ever again, which was great. Caroline, however, was a bit jealous because William getting married meant that Caroline was no longer in charge of the household. So she moved out to live on her own. So she would come back to William's house every day to work on astronomy with him. And they continued to enjoy a very close working relationship. Caroline burned all of her diaries between the years 1788 and 1798. So her exact feelings about that decade are unknown. However, when William and Mary had a son, John Herschel, who was born on March 7th, 1792, Caroline became very, very attached to her nephew. And later in life, Caroline and Mary exchanged very warm and affectionate letters to each other. So if there ever was any ill will between them, it faded away. And you may be wondering why I emphasized so strongly at the beginning that William and Caroline are brother and sister. Well, John Herschel, the son of William Herschel and Mary Pitt, when we talk about the astronomical Herschels, you hear about William and Caroline, then you hear about John, and a lot of lay people assume that William and Caroline must have been husband and wife and their son John. No, John was not the son of William and Caroline. He would not have been a great astronomer himself if he had been, put it that way. That's John Herschel in the year 1829. Now, William Herschel submitted 3 catalogues of nebulas and star clusters that he and Caroline had discovered together. There was the first of these catalogues came out in 1786 and contained 1,000 objects. In 1789, he submitted a second one of a second 1,000 objects. And then in 1802, a third catalog with 500 more objects. So collectively, these 2,500 objects were compiled into something called the catalog of nebula and star clusters. Subsequent analysis, observation, and deep sky photography has revealed that William, yes, he was human, made a few mistakes. The actual number of objects he and Caroline discovered together, is not 2,500. It's only 2,435. There were some errors and duplicates. Now, John continued his father's work. He packed that large 20-foot telescope, he packed it up and he took it to South Africa and started sweeping the southern skies. He also double-checked and revised some of his father's observations to get the most updated positions on these objects. In the year 1864, he published what he called the General Catalog of Nebula and Clusters of Stars, 5,079 objects. As astronomy progressed throughout the 19th century, many other astronomers were writing their own catalogs and making their own star maps, and they claimed to have discovered things that William and Caroline had actually discovered years earlier. Astronomy got bogged down in constant time wasting. Someone would discover a new nebula, and many people would focus their scopes on it, and then realize this is already in the catalog, or it's already in the general catalog. So the Royal Astronomical Society of Great Britain wanted to put an end to this madness. They said, we need one master list. So they hired this man, a respected Danish astronomer, Johann Louis Emil Dreyer. Okay? And they tasked him with compiling a single master list. He did some observations and double-checking himself, but he mostly occupied himself with a monumental task of sorting and organizing all the information of all the astronomers around the world and trying to weed out the duplications and the redundancies. In 1888, he published a completed master list with 7,840 objects, and he called it the New General Catalog of Nebula and Clusters of Stars. New General Catalog. And now you know what it means when I talk about NGC 7789 or NGC 251. Returning to our main characters, in the year 1787, Caroline was awarded a pension of 50 pounds per year by order of King George III for all of her work. This made her not just the first woman in history to be a paid professional astronomer, as far as we can tell, but also the first woman in English history to have a government job. Other than a queen, of course. Okay. William kept busy by making astonishing progress in the field of astronomy. He introduced the word asteroid to daily use. He didn't create that word. Asteroid comes from the Greek aster, meaning star, and eidos, meaning form or shape. So he standardized the use of the term to describe what he called minor planets. By the 1850s, this became the standard term. William studied the proper motion of stars, and he concluded correctly that the Milky Way was overall in the shape of a disk, which it is, a spiral-shaped disk, but the Milky Way overall has a disk outline. William, however, was incorrect in concluding that the sun was at the center of that disk, which it is not. On February the 11th, 1800, William Herschel discovered infrared radiation. He was testing out filters for his telescope because he wanted to look at sunspots. So he obviously would need a very heavy filter to cover up the scope so he didn't burn his eyes out. He noticed that red light filters seemed to generate heat. He then passed sunlight through a prism, and you may remember that image, the classic image of white light going to the prism and separating out to the colors of the rainbow. Well, he passed sunlight through a prism, and he put a thermometer right beyond the red end of the spectrum. And he was stunned to discover that that area became warmer. The thermometer heated up. That area was hotter than any other part of the spectrum. And he concluded correctly, there must be an invisible form of light beyond the visible spectrum. And now you know why heat is called infrared, beyond red. And on top of all of this, William Herschel even dabbled in biology. Using a microscope, because he was enthusiastic about all kinds of optical instruments, he examined coral from a coral reef. And he proved that coral is not a plant. The majority of people in those days believed that coral reefs were basically plants. He proved that coral is an animal, not a plant, because its cellular walls were not characteristic of the cell walls of plants. William founded the Astronomical Society of London in 1820, which became the Royal Astronomical Society in 1831. And in 1813, while reflecting on his life and work, he had the following comment. I have looked farther into space than ever a human being did before me. I have observed stars of which the light, it can be proved, must take 2 million years to reach the Earth. Nay, more, speaking of the Andromeda and other galaxies. If those distant bodies had ceased to exist millions of years ago, we should still see them, as the light did travel after the body was gone. And this is absolutely scientifically correct. William died on August the 25th, 1822. Caroline was heartbroken, and she actually moved back to Hanover. She continued to work in astronomy. She would refine William's catalog with her own observations. She helped John compile his general catalog. In 1828, she received a gold medal from the Royal Astronomical Society. No woman would win that honor again until 1996, Vera Rubin, for studying dark matter. She was made an honorary member of the Royal Astronomical Society in 1835, along with mathematician Mary Somerville, the first two female members of the Royal Astronomical Society. In 1846, at the age of 96, she was awarded a gold medal for science by the King of Prussia. She died peacefully in Hanover on January the 9th, 1848. That is William's tombstone or monument. And the Latin inscription translates to, "He broke through the barriers of the heavens." That is Caroline's monument stone in Germany. And the inscription translated reads, "The eyes of her who was glorified here below turn to the starry heavens." And their legacy still lives on. That is the William Herschel telescope in the Canary Islands of Spain. It is a 165-inch mirror. Big. It's f11. It's a Ritchie-Chrétien design. The Hubble telescope, by the way, is also a Ritchie-Chrétien design. A Ritchie-Chrétien uses two mirrors with hyperbolic curvature. Not easy to make and very expensive. But the light enters, hits the main mirror. In the Herschel telescope, this would be a 165-inch mirror. It has a hyperbolic curvature, and it gets bent toward a secondary mirror, which also has hyperbolic curvature, which reflects it back again toward the rear of the scope into the camera or eyepiece. In the case of a Ritchie Chrétien, it's more often a camera. They're not the best things to look through. There's usually a camera here. And the hyperbolic curvature of the mirrors helps to eliminate many of the optical defects in regular reflecting telescopes. And Caroline is memorialized on the moon. The yellow square symbolizes or shows the location of crater Caroline Herschel. That is a close-up of crater Caroline Herschel, named in honor of the first professional woman astronomer. All right, ladies and gentlemen, that concludes the presentation. I hope you enjoyed that and found it edifying. I continue to draw inspiration from the Herschels, William, Caroline, and John, the greatest visual observers of all time. And I've made it my work to try and see at least the entire general catalog. Maybe one day see every NGC object. I'm up to about 1,100. I've seen that many so far. And thank you for your time and patience. If any of you have questions, feel free to unmute yourself and raise your hand. But other than that, that concludes the presentation itself. Thank you so much for your patience. I want to stop the recording now.